Good afternoon, guys. This is the tutorial for Chapter 6, Further Circular Motion Applications, Centripetal and Tangential Forces. Let's see that. There it is. The first problem with different values will be the same idea. You have a standman with certain mass, with a rope hanging. So the diagram will be basically, you can have the roof, right? And you will have a person that is gonna be swinging from, say, this point. The length of the rope doesn't change. So it's going to reach a point here at the bottom, and the speed is, in this case, 8.1 meters per second. They give you the breaking strength of the rope. We know it has a tension, and we know the standman has a mass, so you have a weight in G, and because of the speed, right, we know it's going to be accelerating centripetal force in here. We have to find out if the tension will be able to support the standman at this speed. So we have done this in the lecture. Tension minus mg equals to the centripetal force mass times v squared divided by r, where r will be the length of the rope. You want to find this tension. The mass is given, gravity is 9.8, the velocity, the speed is given, the radius is, and then you find the tension. You can answer this. And then for what is the maximum speed? To know the maximum speed, you want to do this equals to 1,000. So he can safely cross the river. So for part B, you want to do 1,000 minus mg, which will be approximately 870, will be equals to mv squared divided by r. And that's how you find the maximum speed in meters per second. So it's a very easy problem. This one is similar. Now you have a roller coaster, right? It's going to go down and then up. So we have done this in the spinning wheel on A, right? You will have the normal going up, but mg is going down. But we know that there is a centripetal force also going like that. So just like we had before, normal minus mg, now it's a normal, minus mg equals to the mass times v squared divided by r. That's how you get, and then they tell you that the speed of the vehicle is 19.1 on point A. So you use 90, well, whatever you are given on this part. For part B, the forces diagram will be mg going down, the normal always goes upward, but you have the centripetal force going down now. So mg minus the normal equals to the mass times v squared divided by r. And what's the velocity on B? Oh, you don't have to do in part B, sorry. For part B, it says, what is the maximum speed so it remains on the track? Well, we've done that before. For part B, the maximum speed will be when the normal is 0. That means when mg is equal to mass times v squared divided by r. So you don't need the mass. You have the value of the r, r2 for this, and you can find the speed like that. We done a problem of the pendulum, right? You have an object with certain mass. So it's here, so you guys remember how we did that forces diagram. We have a pendulum. I want to exaggerate the angle here just to make it more obvious for you guys. You have a mass M, and you have the angle theta. So it doesn't matter if it's going like this or like that. The forces diagram doesn't change. You still have mg. This could be a good problem on the quiz, by the way, or an exam. So this is 90 minus theta. So if I extend this line, and I know this is 90 degrees, so this will be theta. I mean, it makes sense, right? Complement, corresponding angles, parallel lines. This is parallel to this, 90. So I can find this component and I can find this component for the weight. It will be mg cosine, mg sine. Mg cosine theta. So radially, we know there's a tension here. So to find the tension in the core, remember that tension minus this is the mass, mg cosine theta, and they give you the speed of the object. Is equal to mass times v squared divided by r, which is the radius of this circular motion, which will be 2.5 meters in this case. All right, so they give you everything here, right? That's how you find the tension. The radial acceleration, the centripetal acceleration will be just v squared divided by r. How do you find the tangential acceleration? Here. Mg sine theta is equal to mass times tangential acceleration. So the tangential acceleration will be g sine theta. Okay, and you're also given the value of theta there. How do you find the total acceleration? Okay. The total acceleration is the square root of the tangential, let's put here tot, square plus radial or centripetal acceleration square. Okay? Let's check number 5, because this one is actually a problem that you need to be careful. It's easy if you have done the conic pendulum, like the one that we just did, but you have to realize that you have a wheel rotating, like in an amusement park, as they show you in the picture, and you have chains. So the projection on the plane of this diagram, it's probably not as obvious, but let me just show you guys. This will be the diameter of the wheel, all this. This will be the center. And the wheel is rotating. The chains that they tell you in the problem start from here. So this is the axis of rotation now. Okay? So maybe I should draw it like this. It's like the center. So clearly, now in this case, so we are giving here a mass. You're giving here the chain with some tension. And they tell you that the angle is, let's say, 31. Let's make it 30. Well, 31. They give you the diameter, right? The diameter. Okay, they give you two diameters. The big D is all this. So this is 3. This is 7 meters. This is 3.5. And this is also 3.5. You see, you need that 3.5 to add to this length to find the total radius of the chains going in the circular motion. What is this? Well, they give you the length of the chain. They tell you that they are 2.5 meters in my problem here. So I need to find this angle, which I can do because I know this angle is 90. If this is 31, this should be 59. Now, what's here? mg. And what was here? The component of the tension. Here you can also break it, right? And now you have all this, right? So tension sine 59 is mg. Tension cosine 59 is the centripetal force. To find the speed, you don't need a tension. So you can put tension sine theta. I'll put theta here. 59, right? Is equal to mg. And tension cosine theta is mass times v squared. What is the radius? Is all this. So this was 2.5. All this length was 2.5 cosine 59. So if I grab the calculator here, um, 59 cosine times 2.5, that's the radius here, plus 3.5. That would be the radius I have to write here, 4.78 or 4.8. And then you divide the equations and you get tangent of theta, which is tangent of 59, is equal to G times 4.9, 4.8 divided by v squared. And then you can find, you see, you have gravity, you can find the velocity. That's what they're asking you in this section here. You want to draw the forces diagram? I already showed it to you. The tension, you will find it replacing back, right? Oh, guys, remember that you have a 40 kilogram child. The mass of the shell is also given here by little m. So you have to add them together to have the total mass, okay? Don't forget about that. So that's not bad. This is theoretical. This one, the tension that you are pulling is basically the centripetal force. A string under a tension, they give you the tension of that, is used to make a rock go around with a radius of 2.7 with certain speed. As the string is pulled, the speed of the rock increases. When the string on the table is 1 meter long, and when the string of the table is 1 meter long and the speed of the rock is 50 meters. Why is the breaking string in newtons of the string? 51 is mass. Oh, okay. So they give you the first piece of information to find the mass. Yeah. And then you will use that mass with the speed to find the breaking strength. That's it. So 51 point in my problem, right? The tension given will be the mass of the rock times the velocity square divided by the radius, which is 2.7. And then to find the breaking strength, will be this, you will find you use this mass times the speed now that you have 50.5 square divided, 50.5 square divided by the length now, which is 1. Let's say that's an easy problem. This one is the same idea as the roller coaster. When you go up on a bump with certain speed, remember to change kilometers per hour to meters per second. For example, if I have 22.4 kilometers per hour, what I do is I multiply by 5/18. Okay, that will give me the speed in meters per second. And in here you have the normal. Let's actually do it properly. Let's use this. You have the normal. You have mg. And you also have the centripetal force going like that. So, you know, in this case, mg, because they ask you for the magnitude of the force the road is exerting. They're looking for the normal in this problem. It's equal to mg squared divided by r. So many of these problems use the same concept, right? So this homework should be very simple. All right. And then you have the conical pendulum. All right, guys, I hope this tutorial helps. It was like 20 minutes, but this homework should be very simple. I want you to start getting ready because the next chapter will be uploaded soon. We'll start with work and energy. All right, I'll see you guys later and have a good week.